fairly close to the last one I did, but I thought I'd take a look at another 12 volt lamp. I bought the two of them at the same time. The one that was in this housing with the sort of strange structure of the metal filaments. And this one, which is more a traditional sort of glass filament lamp, quite nice. The way that they're doing it, notice that I've got everything marked 12 volt and 12 volt on this. I do that when I get one of these lamps in, otherwise I will stick them across 240. And in my experience, the simpler LED lamps aren't that exciting when you connect them across 240. They tend to fail in a rather controlled manner. The ones with the electronic circuitry, on the other hand, they go boom and make nice satisfying pops. Much like the thing that I plugged into this death adapter yesterday. Quite late last night, it was very exciting. That will be in another video. I should have been videoing it. I wasn't videoing it. I just thought, let's check a voltage, and the voltage turned out to be boom volts. So let's stick that out of the way. We have our lamp. It is glass. Let's do some tests. Where is my power supply on? Let's stick loads of meters in here. Let's get the thing analysed properly. So this is the sort of two LED filaments, and they're both in series. Let's see if there's a regulator in it. So I'll bring in a couple of meters. Let's bring in the bench supply here. Let's get that set to a sensible voltage. So we'll put the positive on the live pin, so that's the middle pin in this, because it is polarity sensitive. I've checked that beforehand. It won't work if the polarity is the wrong way around, which is a wee bit annoying, but you know, it just means it's simpler and more efficient. Let's set this to 20 volts and see if it behaves itself this time. It didn't behave itself last time. So let's hook that on to there. This is where the sleeve pins actually can be a bit of a nuisance. And let's bring the leads down here. Yeah, I've already popped one off. There we go. That's a great start. Let's turn this to DC amps. So that's the 2 amp range DC, and I'll null that out. I'll zero it out. So we've got a power supply now of, filaments are glowing, 10.6 volts. It's just starting to glow. It's actually, you know, it's not a bad intensity. The current is 6 milliamps. Let's turn that up. Let's turn it up to the full 12 volts. So let's go by this meter down here. 12 volts, that'll do. It's 60 milliamps. So what's that? That's not a full 2 watts. 12 volts times 0.06 equals, that's 0.7 watts. It's still quite bright for that. But in a vehicle it might go up, because I'm guessing that's the application, it might go up to say about 14 volts, typically. Let's crank it up to 14 volts. Oh, it's getting bright now. It's getting very bright now. I hope it's not going to over. So 14 volts, calculator back in. 14 volts times the 163 milliamps, that's 0.163, equals just over 2 watts. So this is clearly optimized for the operation on the sort of car use where it's going to go up to 14 volts. It's quite nice. It's good enough that I could see lamps like this becoming viable for running a 12 volt system in your house. Got to turn that down because it's a bit glary, isn't it? Let's see, just out of interest, for visual effect, if you just wanted this type, someone recently mentioned that it would be quite good in sort of cosplay type costumes with the sort of the electro look with the lamps. This is currently running at 10 volts, so you could actually run these off a battery pack, and the current, well, let's turn it down to what we're going to get around about 20 milliamps. About 11 volts gets you about 20 milliamps, and it gives a good visual effect, but it's going to give a good long sort of battery runtime for use in a sort of prop or costume or even as an ornament. That is acceptable intensity. It's not bad at all. Anyway, I digress. Let's get rid of all this stuff and let's open the lamp. So let's turn the power supply off. I like the fact that it's one of the first 12 volt lamps in this LED ones that is styled in a proper lamp with the full sort of glass filaments and things like that. I also noticed that if you turn the voltage up slowly, it starts lighting round about, let's bring this back on again. The filaments start to glow round about 10 volts, roughly 2.5 volts. That suggests that there's two sections in each of these filaments, and that is just basically probably just got a resistor in here. That's my guess what's inside. A resistor and then just a double section, so each of these filaments represents a voltage drop of roughly 6 volts at full intensity. Very, very simple. Let's open it. I'm going to do my usual here. I'm going to peel. There's a wee hole in the side of this here. Is that for letting smoke out? What does it say on the side? It says XM-18-09. Oh, it's a manufacturing date, by the look of it. Let us probe this. What do you reckon is going to be inside? Is it going to be a resistor? That would be the simplest thing, and certainly the way it's behaving does suggest a resistor. I can already see the resistor in here. That's what we like to see, something super simple. I may have to, because it's so short, I may actually have to prise off the stud here. This is where I slip with this blade and stab myself. Oh! Yeah. Or snap the blade and ping it across the room. That's alright, I'll get eye protection on. I always have eye protection on. There is an advantage to wearing glasses. Oh yeah, that is so sweet. That is so simple. I like that. And that does tally up with the each filament just being an array of LEDs. I should have actually counted the number of LEDs, shouldn't I? I didn't. I'll do a rough count of them now. So here's the resistor. It is brown, black, black, so that's 10 ohms, 1 0 and a 0 multiplier. We can double check that. I should bring in the daddy meter, the domometer. It's bigger, it's bolder, it's rougher, it's tougher. This is not an advert for Fluke, it's just because, you know, Fluke is what I have at the moment. 10 ohms. Well, that's overtly precise, isn't it? Whoa, too precise. Oh, that's very good. Wow, maybe I should use a professional meter. So, if I connect the leads back up to this then, if I connect positive to here and negative onto this rag of metal that I've left at the side, and I turn the bench power supply on, oh, I've got a nice setting for that. Let me try and count this. It's always so hard counting these tiny little dots in parallel. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 30, 40, 50, 60. I would say there's about 20 chips in this. It's very hard to say, because it's very hard counting them like that. Normally, to get an accurate number, I'd take a picture of it, and then I'd put a dot on each one as I count it, because it's just, it's very, when you've got so many little dots in the vicinity of each other, it just makes that a little bit harder. But I would say there's about 20 chips in each filament, and I'm guessing that the first 10 are in parallel, and then they'll be hooked in series, the next 10 in parallel. That's nice. This is an interesting lamp. Ooh. Oh, that's, I thought, oh, I'm way overdrive it. I'm not. That's, blimey, it's actually capable of taking quite a... Yeah, at the full 2-watt rating, that is intense. So yeah, this could be the future of housing, could be a DC bus going round. You could have if you were prone to power failures in your house, your whole house could be fitted with lamps like these 12-volt glass globe lamps, the filament lamps, which I've found to be very, very reliable. And you could have a battery that powers your DC lighting circuit with just switches, or you could have the pulse and modulation dimmers. And it means that in the event of a power cut, if you had something topping that battery up, and then in the event of power failure, it just the lights are across the battery all the time perhaps, or it just changes over, then you wouldn't even notice a power failure had occurred, because the house would be just lit up at full intensity as normal. So that's nice. I do like this lamp. I shall provide a search link for it if I can. I'll either provide direct link to the eBay listing, but I prefer to actually make a search link because that way the price of that listing won't go through the roof if you all start ordering them. So yeah, this gets top marks. Where was the case for that? The box. This is what the box looks like, just in case that's a clue on the listing. And it's available in different wattages as well. One other thing I could do, let's put this up to the full whack and measure the voltage across that, the voltage drop across that resistor, because that will give us an indication of its dissipation. I don't think it's going to be that high. So let's put this up to about 14 volts, as if you're running it in a vehicle and it is charging at full whack. Let's check that voltage. Oop, 13.8, good enough. And let's measure the voltage drop across that resistor. Ah, 1.7 volts at 175 milliamps. Let's do the maths. Let's say 1.8 volts there. 1.8 volts times 0.177 equals, it's a third of a watt. It's, you know, it's barely more than a quarter watt resistor type of thing, but this is a well-rated resistor. Now I wonder if the 4 LED filament versions actually use a similar sized resistor though. I wonder how hot that would get, but having said that, not half as hot as the old neon lamps used to get because they had quite a drop across that resistor. This is very intriguing. Yep, I do like that. Top marks.